Hello everyone, welcome to my video lecture on Laplace transform versus Z transform. In this video, I'm going to discuss about some of the properties and the formula comparison, and it's me, Mohammad Imran sir from Triple Department. Coming to slide 1, this is the introduction slide which discusses the main comparison between the Laplace transform and the Z transform. So Laplace transform is used for continuous time signals, whereas Z transform is used for discrete time signals. This is the difference between the Laplace transform and the Z transform application. And more importantly, there are complex variables in Laplace transforms like real part plus imaginary part, and it is used in the integral transform. On the other side, this is for complex variable Z in the Z plane, and summation transformation it is being used for, which is a Z transform. Moving forward with our next slide, first property that I would like to discuss is about linearity. The linearity in Laplace transform is given as Laplace of a f of t plus b g of t is equal to a f of s plus b g of s. Similarly, in Z transform it is in discrete form, that is Z transform of a x of n plus b y of n is a x of z plus b y of z. This properties is for Laplace transform and Z transform is the linear property. This is a linear property for Laplace transform and Z transform, in other words. Moving forward with time shifting property for both Laplace transform and Z transform, the Laplace of f of t minus t naught into u of t minus t naught is e power of minus st t naught into f of s. Similarly, in Z transform we have z of x of n minus n naught is equal to z power minus n naught of x of z power minus n naught into x of z. This is the scaling in time, which is nothing but in Laplace transform it is Laplace of f of at. If it is scaled by a, then it is 1 by modulus of a f of s by a. Similarly, in Z transform we don't have no simple time scaling that exists in Z transform. So one needs to know that there is no scaling in time using Z transform. Now in this slide, we will discuss about the convolution theorem using Laplace transform and Z transform. Convolution theorem using Laplace transform is Laplace of f of t into g of t is equal to f of s into g of s. Similarly, using Z transform is z of x of n into y of n is x of z into y of z. In regards to the initial and final value theorem, this is a very important slide. One must know that in Laplace transform and Z transform there are two theorems. One is initial value theorem and other one is final value theorem, and these formulas needs to be noted. The region of convergence, ROC in short, deals with the stability of the system. In order to decide whether the system is stable or not, we need to check for the zeros and poles in the S plane on the right half plane. For example, if you are using the Laplace transform, and if there is a Z transform inside the unity circle. Some of the applications of Laplace transform include control systems, circuit analysis, and differential equations, whereas the applications of Z transform includes digital signal processing, digital filters, differential equations. Thank you for watching my video. Thank you once again, and stay tuned and await for the next videos. Thank you. Thank you for watching this video. This was a trial video with your class to test how we are comfortable with the video sessions or not. And also I wanted to give the recordings to the students so that it comes as an handy for them. Stay tuned for more videos, and please do not forget to like, share and subscribe my new channel, Signals to Scope with Imran.